right, so this portion of the Nearpod is being recorded in class. All right, so this is for first period. All right, so there are 5 blue, 4 red, 1 yellow, and 2 green beads in a bag. Find the probability that a bead chosen from the bag is blue. So first of all, class, what's our total number of beads? 12. So that's always good to find your total first. All right, so probability of blue. Let's see what we got left here. Anybody at the purple table? How about the probability of green? Blue 3. And we'll reduce that one to 1 out of 6. How about the probability of blue or green? Now, so this is this. Now, so the probability of blue, actually I'll write this in black first, is equal to the probability of blue plus the probability of green. Color code this one. And then minus the probability of blue and green. All right, so answering this question for us. Orange, no. We have a green 1. Do we have an orange 1? No. Oh, I got a big pile of sticks over here too. Orange 5. Got an orange 5. All right, so what's the probability of the blue? 5 over 12. And then how about the probability of the green? That's a 1, 2. So 2 over 12. And then we want to subtract the probability of blue and green. So what's the probability of getting blue and green? No. No. How many blue and green beads are there? Blue and green at the same time? None. There are no blue-green beads in here. All right. So notice there's no intersection between these. It's either blue or it's green. There's no blue and green. Right. So you can't pick a bead and have it be both blue and green. So it's just going to be the sum of these two is going to be our answer because these are mutually exclusive. Right? So when the two events are mutually exclusive, there's nothing to subtract off. There's nothing in the intersection. So these have nothing in the intersection. So we'll have the same thing will happen with blue or yellow. Right? So it would be the probability of blue plus the probability of yellow. Well, I can't really write in yellow here. So I guess I'll write in red. Probability of yellow. And then we'd subtract the probability of blue and yellow, the intersection, but there's nothing in the intersection. So how about the rest of it? Yellow 4, no. But we had yellow 3. I didn't call yellow 3, did I? Yellow 3. So what's the probability for the blue? Yep, and the probability of yellow. And so our answer then would be 6 over 12 or 1/2. Right? Because there's nothing in that intersection. So if there's nothing in your intersection, you're not actually going to subtract anything off. So for mutually exclusive, it is just going to be the sum of those because there's nothing in the intersection. How about the probability of not red? Purple 3. Probability of not red.
2/3.
Well, give me the unreduced number. So how would you find the probability of not red? What would you do to find that?
Well, to find the top number, I just did the total minus all the others.
So you took,
Actually, wait. No, I did the total minus the number of red.
and that works. Yeah, so you can do 1 minus, so what's the probability for red?
4/12.
Well, it was 4/12, yep. So you can use the complement and just subtract from 1, and that would give you 8/12, and that's how you got 2/3. You could also, it's not wrong to say 5/12. It's a little longer, but it's not wrong. 5/12 plus 1/12 plus 2/12, right? That's the blue, the yellow, and the green, and you'd still get 8/12, which is 2/3. A little faster to use the complement, but both of those give you the same answer. Just kind of want to show you that. All right, so now probability of not yellow, right? And I think I'm back to the beginning. Except they didn't call orange 1 or orange 2. Which one do I have, orange 1 or orange 2? Orange 2. So Corey, how about the probability of not yellow? Yeah, so we could do 1, the whole thing minus. What was the, so we can do 1 minus the probability of yellow. So what's the probability of yellow? There's only 1 yellow. So that would be the easy way, is to use the complement. All right, so here we'll just go right ahead and use the complement. Right. Any questions on these? These were all simple probability and a little bit involving the addition rule, but these are mutually exclusive. So we're going to look at multiplication rule and add that to our list of things that we know how to do. All right, so we're going to determine whether events are independent or dependent, find the probability of independent and dependent events, and we're also going to find conditional probability as well. So some vocabulary words: independent events, dependent events, conditional probability, simple event, compound event, mutually exclusive events, and inclusive events. So we'll still review the mutually exclusive and inclusive events, as well as some new things: independent and dependent and conditional. Independent and dependent didn't play into addition rule, plays into multiplication. So let's take a look at some information for you. All right, so this is I did not save myself a set of notes. All right, so events are, fill in there for you. Fill in the words independent events in your notes if the occurrence of one does not affect the probability of another. So for instance, tossing coins. What you get on one coin does not influence what you get on the next toss. Right? It doesn't work that way. All right, so they're independent of one another. All right, so here the probability of tossing heads. So if you toss a coin, there's a heads and there's a tails. So you have a probability of 1/2 of getting a heads and 1/2 of getting a tails. There's 2 options and there's 1 of each. If you toss the coin again, you still have a probability of getting a heads of 1/2 and the probability of getting a tails is 1/2, regardless of what you got on the first toss. It doesn't make any difference, right? So if we want to find the probability of tossing a heads twice, right? So probability of heads, head. We're going to take the probability of getting 1 head, which was 1/2, times the probability of getting the second half, which is also probability of getting the second heads, not second half, second heads, which is also a half. And so the probability of getting 2 heads is 1/4. So the probability of independent events, if A and B are independent, then the probability of A and the probability of B is the product of the two probabilities. So this is for, we were only dealing with one a simple event in the last lesson, and we added. When we have two events, we want to find the probability of more than one event, we have to multiply. Okay, so this is hence the name multiplication rule for this lesson. All right, we're finding the probability of more than one event, we're going to multiply. So it's the product of the probabilities. And actually, each of these outcomes has a probability of 1/4. We'll be looking at trees for probability. They are on Easy Merit. So each one of these, to go down the tree, we would just multiply. 1/2 times 1/2 is 1/4. 1/2 times 1/2 is 1/4. 1/2 1/2 is 1/4, and 1/2 times 1/2 is 1/4. So exactly. Yep, you have a probability 1/4 the time of getting two heads, of getting a heads and a tails, getting a tails and a heads, or getting two tails. Those are all have the exact same probability.
All 1/4.
Yep. Right, so if in your notes, events are dependent events if the occurrence of one event affects the probability of another. For instance, suppose there are 2 lemons and a lime in a bag. If you pull out 2 pieces of fruit, the probabilities change depending on the outcome of the first. Right, you're changing what's in the bag. So if I take out one of the pieces of fruit and I go to pick again, I don't have the same fruit in the bag. Right? So the tree diagram here shows the probabilities for choosing 2 pieces of fruit from a bag containing 2 lemons and 1 lime. All right, so the probability of getting, in the first pick, the probability of getting a lemon is 2/3 because there's 2 lemons. And probability of getting a lime is 1/3 because there's 1 lime. Once you picked a lemon, though, now you've got 1 lemon, 1 lime. You've got a 50-50 chance of getting a lemon or a lime on the second pick because that's all there is. There's a lemon, there's a lime. Yeah.
There's a 100% chance you're going to get a lemon.
Yeah, exactly. So if you pick the lime, all you can get is a lemon because there's no limes. So, yeah. So to find the probabilities of each of these things occurring, so this is the probability of lemon, lemon. So I write it like this because there's 2 events. It's not lemon or lemon, it's lemon, lemon. All right, the comma there means 2 events. This is 2 events. So the probability of getting a lemon then a lemon would be 2/3 times 1/2. So that would be 2/6 or 1/3. I have a 1/3 chance of getting the 2 lemons. The probability of getting a lemon then a lime is also 1/3, right? That would still be 2/6. So after I get the first lemon, I have to get either a lemon or a lime, and it's a 50-50 shot. The probability of getting a lemon then a lime is going to be 1/3 times 1, which is 1/3. And the probability of getting 1/3 a lemon then a lemon, well, that's 0. I mean, a lime and a lime is 0 because there's not 2 limes. So that's not possible. Let's take a look if we add up the probabilities here on the 2-factor trees. So if we add them up, what is 1/4 plus 1/4 plus 1/4 plus 1/4 equal? What's 1/4 plus 1/4 plus 1/4 plus 1/4? What would that equal? 1. Let's let me finish this part up. Let's look at one more thing, and that is, let's add these ones together. Oh, come on. So what is 1/3 plus 1/3 plus 1/3 plus 0 equal? 1. All right, so all the options added equals 1, right? Because that's all the options you have. There'll be a near part, and we'll pick up at this point on the lesson. So it's going to start right over here on the next part.